Hey, what's up guys? It's Ryan from Parity here, and today we're going to be going over the last layer for Skyscraper method. Now, this is part 4 in a 5-part series on the Skyscraper method, so if you have not seen the first 3 parts, go check those out. Link will be in the card, and come back when you've seen those. So when you're solving the last layer using Skyscraper method, the main thing that makes this different than last layer on a 3x3 is that you have to deal with the multi-edges. So we have to pair those or triple those up before we can finish the last layer. To start with, let's go through all of the cases on the 4x4, starting with 2 edges unsolved. Now the first case we're going to look at is the case where the 2 edges that need to be paired are right across from each other. So as you can see, the 2 orange are across from each other and the 2 blue are across from each other in this case. So this is the algorithm we will be using for that case. Here it is slowly. And here it is quickly. So basically what we did here is we cycled these 3 pieces. And how we did that is we moved this one down, we flipped this edge over, we moved this back up, and then we flipped this edge over again. Understanding this is really helpful for our next case, which is this case, where the edges that need to be paired are diagonal from each other. So the algorithm we're going to use for this case, we're going to flip the edge first, bring this down, undo the flip, and bring it back up, as opposed to doing it the other way around. So how the algorithm for this one is this is what that algorithm looks like full speed. The last thing that can happen is where the edges that need to be swapped are adjacent to each other like so. And what you need to do in this case is apply this algorithm. And then do whichever algorithm solves the case that you get after that. Now let's move on to 3 edges that need to be solved. What you're looking for in this case is 2 edges across from each other that can be paired by a slice move like so. Why we want this is so that we can put them together and then sub in this last edge, so you can see this orange needs to go with this orange, and then put it back and then undo our setup moves. Let's look at it again. This one needs to go here, and this one needs to go here, and this one needs to go here. Up, setup, move down, undo setup. This is pretty standard stuff. It's very much similar to reduction on a 4x4 or a 5x5, and you should be able to figure that out on your own. You will sometimes have a case where the 2 edges that are across from each other are not diagonal, so you cannot pair them with a simple slice move. As you can see, if I slice up or slice down, we have no edges paired. What you have to do in this case is you have to apply this algorithm, and it will put these 2 such that one of them is here and one of them is here. This is the algorithm. And as you can see, what that did is that paired these 2 edges up so that we can do that and then do our reduction like normal. So for cases with 4 edges that you need to solve, you need to again look for 2 that are diagonal from each other, pair them up, and then sub in another edge. And then you will be reduced down to either 3 edges or 2 edges and continue from there. Similarly to with the 3 edge cases, if you have none that are diagonally across from each other, you just look for 2 that are vertically across from each other and perform the same algorithm. And that will set you up with 2 that are diagonally across from each other, and you can proceed as normal. If you have a case where there are none across from each other, diagonal or otherwise, what you want to do is you want to do a slice over, and then do you see how this one needs to go here? So what you do is you sub this single edge in, and then you move this back, and then you undo your setup moves, and you've solved an edge. 5x5 works just like 4x4, except for that you will also have to deal with these central midges. This isn't too hard, it just requires us to add a extra step and a couple more algorithms. Similarly to on a 4x4, when you're solving the last 3 midges on a 5x5, you're looking for a way to solve a single midge using a single slice, such as like this. Then you would move this over as normal, like you would on the 4x4, move that back and undo it. Sometimes you'll have a 3 midge case that cannot be solved using a slice move. Sometimes it'll look like this. And in this case, you can use a modified 3x3 U-perm to solve it. The algorithm we're going to be using to cycle them this way looks like this. So you want to use a combination of the modified U-perms and the slice algorithms to get yourself down to a position where you either have 2 edges left or 1 edge left flipped or something along those lines. And I will leave a link to a bunch of parity algorithms you can learn to help make this easier in the description. I did not come up with these parity algorithms, I just found them and that PDF turned out to be extremely useful. So that about does it for this video. This was part 4, the last layer, and after this you should be able to solve the entire cube using Skyscraper method. The next video will be on tips and tricks to get faster. It'll go into a few more advanced algorithms and just kind of general thinking I've developed about the method. But that about does it for this video, and I will see you guys in the next one.